I welcome all the children of class 10 for today's session on electricity. In the previous module, we have studied what is electric current and what is potential difference. The relationship between electric current and potential difference was given by German physicist George Simon Ohm. This relationship is known as Ohm's law. Ohm's law states that the electric current flowing through a conductor is directly proportional to the potential difference applied across its ends at constant temperature. Mathematically, this law can be stated as potential difference V directly proportional to electric current I, V equal to Ri, where R is proportionality constant and is known as resistance of conductor. A conductor has large number of free electrons inside it. These free electrons drift from one end to the other end of the conductor. As these electrons move, they collide among themselves and they also collide with the ionic lattice of the conductor. Because of these collisions, the movement of free electrons will be affected. If the collisions suffered by the electrons are more, then resistance also will be more. The collisions suffered by the electron also depends on the arrangement of ions in the lattice of the conductor. We can define resistance as the property of the substance to oppose the flow of electric current through it. From equation, we can say the resistance of a conductor as the ratio of potential difference across it to the current flowing through it. The SI unit of resistance is ohm. Ohm is denoted by the Greek letter capital Omega. 1 ohm is the resistance of a conductor when the current of 1 ampere results when a potential difference of 1 volt is applied across it. Let us study an activity to verify Ohm's law. We actually verify the relationship between electric current and potential difference in this activity. We need few materials like ammeter, voltmeter, resistance wire and 3 cells in this activity. Initially, we connect one cell in the gap shown in the circuit, and then readings of ammeter for current and voltmeter for potential difference will be noted. This process will be repeated with 2 cells and then 3 cells connected in series. The readings of ammeter and voltmeter are all noted down in the tabular column. We find the ratio of V to I for each of the observations. A graph is also drawn between potential difference V and current I. From the activity, we observe that as the number of cells are increased, the readings of voltmeter and ammeter also increases. We observe that ratio of V and I is same in all these cases, and the graph is also a straight line, which actually verifies that V and I are directly proportional to each other. Thus, Ohm's law is verified. A substance which obeys Ohm's law is called as ohmic conductor. Copper, aluminum, silver, etc. are all ohmic conductors. The VI graph for a ohmic conductor is a straight line passing through the origin. A substance which does not obey Ohm's law is called as non-ohmic conductor. Electrolytes, filament of bulb, p-n junction diode, etc. are all non-ohmic conductors. The VI graph for a non-ohmic conductor is not a straight line. Resistance of a conductor is directly proportional to its length. It means that resistance increases on increasing the length of conductor. Resistance of a conductor is inversely proportional to its cross-sectional area. It means that a thick wire has more cross-sectional area and less resistance. Resistance depends on the nature of material of conductor. It means that resistance will be different for nichrome wire and copper wire with same length and area of cross section. The resistance of a wire also changes as the temperature changes. As temperature increases, the resistance of the wire also increases. A fair comparison of different materials to conduct electricity is possible by measuring their values of resistivity. The resistivity of a material is numerically equal to the resistance of a conductor of unit length and unit cross-sectional area at certain temperature. The unit of resistivity is ohm meter. Silver has the lowest resistivity and is considered as best conductor. Copper and aluminum are also good conductors of electricity. Copper is relatively less expensive and is used extensively as electrical connecting wire, and aluminum is used in the overhead power cables of grid. The resistivity of metals is very low. The resistivity of alloys is much higher than those of pure metals from which these alloys are made. Example, nichrome. Nichrome is an alloy of nickel, chromium, iron and manganese and is used as heating coil. Resistivity of insulators is very high. Tungsten is used extensively for making filaments of incandescent bulbs. The resistivity of tungsten is high when compared to other metals. The filament gets very hot and emits light. It must not melt even at high temperatures. Tungsten has very high melting point, which is 3380 degrees Celsius. The bulbs are usually filled with chemically inactive nitrogen and argon gases to prolong the life of filament.